HoloBIM is a software application for the design, detailing, and quantity takeoffs of reinforced concrete buildings. It consists of two standalone modules: the structural design module and the detailing module. The structural design module has been on the market for the last 20 years and has more than 3,000 active users. This video is a demonstration of the detailing module. The detailing module deals with the implementation study of the whole building, which results to the construction detailing drawings, the quantity takeoffs, and the cost estimation. It concerns all professionals involved in the design, supervision, and construction of buildings: architects, civil engineers, CAD designers, contractors, developers, and to technicians of various specialties. The following video demonstrates the real-time creation of a project in HoloBIM. This is a tutorial video for the novice users. The video also contains narration of the actions performed. After the creation of a new project, the engineer can analytically describe the geometry of the building. We can drastically decrease the time needed for the description of the various structural elements by using an architectural drawing as background of the working layout. The imported drawing is dynamically processed, and the OSNAPS tools can be used in order to specify the insertion points of the structural elements without having to use the exact coordinates for each element. We can define the fixed point of each column by using the Properties dialog box. The same dialog box contains all available column types and other important properties that should be defined. All custom-shaped columns can be described as a combination of shear walls, which will be eventually unified in a composite element. This element is calculated, reinforced, and founded as a single structural element. The elevator can be either described by using the available column type, or by combining shear walls in order to create the composite section of the elevator. These shear walls should be then unified into a single structural element. The software offers a wide variety of column types, and the user can even combine different types in order to create the composite column sections necessary for a specific project. The structural elements used are not just graphical representations. They are three-dimensional logical entities with specific properties. This allows for the simultaneous visualization in 2D and 3D view. The description of the beams is also a very simple procedure. The precise connection points of beams and columns are automatically recognized, and the 3D model is instantly created. Every beam has its own unique properties. The engineer can easily modify these properties for an individual beam or for a group of beams. A continuous beam that runs through several columns can be described by selecting the fixed point of the first column and the fixed point of the last column. The intermediate columns are automatically recognized. The simultaneous display of the 2D and 3D view of the structure allows for the easy detection of possible mistakes in the description of the frame. What is more, it offers the engineer an overall detailed view of the described frame. The software automatically calculates the edges and creates the slabs when the user clicks with the left mouse button inside a slab. Cantilevers can be described by drawing their contour line. It is possible to create complex cantilevers by using a combination of several rectilinear or curvilinear lines. The description of the staircase is completed in two simple steps. HoloBIM supports many types of standard staircases, as well as the custom-shaped staircase. The engineer does not need to do anything else regarding the staircase and its influence on the structural frame. Formwork detailing, sections, dimensions, drawing papers, quantities, and cost estimation are updated automatically. We have the option to copy one or more floors, in order to avoid redescribing floors which are identical. This option will drastically decrease the time needed for the description of buildings with identical floors. All required corrections can be performed at any moment during the description phase. We can now continue with the description of the basement shear walls. After describing the basement shear walls, we can erase the basement beams which are not necessary any longer. The engineer can select from various foundation types. The application supports mixed foundation solutions, for example, a combination of footings and footing beams in the same or in different elevations. The description of the structural frame is now finished. We will continue with the description of the walls, the openings, and other architectural entities. HoloBIM contains over 100 different types of walls, for different types of buildings and environmental conditions. The engineer can modify these walls according to the specific requirements of the building, or create a completely new type of wall by combining layers of materials. For this specific example, we will select a wall with an external insulation of 100 mm. The description of walls is similar to the description of beams. We use the mouse to select the starting and ending point of the wall, and we can modify its properties as needed. The walls are unique architectural entities which have their own properties, geometrical data, and quantity takeoffs. According to the BIM design, every modification of the wall's properties automatically updates all drawings and quantity takeoffs. For the internal walls, we select a single 120 mm wall, without insulation. The description of walls is even faster when we use the architectural floor plan as background. The walls are dynamic entities which can identify their intersection points and automatically adjust. The next step after the description of walls is the description of all doors and windows. HoloBIM contains an extensive library of frames. Each type of door and window has its own properties which can be modified according to project requirements. We can select the orientation of the frame by selecting the appropriate side of the wall. The geometry and quantities lists are automatically updated after every change we make. For example, when we add a window to a wall, the frame's hole is removed from the wall's geometry and from the quantity surveying lists of the materials. Modifications and corrections are completed instantly. We don't need to erase the wall in order to create the new window. We will continue with the description of internal door openings. Every property of the door, for example the width of the opening, or the height of the door, or the thickness of the case, or even the material of the sill, can be modified according to specific project requirements. The feature to copy and create typical floors can significantly reduce the time needed for the description of the building. We have now completed the description of the whole building, both its structural frame and its architectural elements. With the help of HoloBIM tools, the description of the 8-story building was completed in about 20 minutes. We will continue with the implementation of external insulation for the structural elements. We can modify the insulation for the whole building, a specific floor, or even a specific structural element. HoloBIM includes a tool to create floorings from grout concrete. The last step is the implementation of plaster for the whole building. In only a few seconds, all internal and external plaster layers are created for the entire building. It should be noted that what we saw until now, and what we will see next, is done with a conventional notebook with a high-definition screen, and is in real time. Let's now look at some additional HoloBIM Construct outputs. We will now select a variation of the previous example. This project is completed up to the plaster phase for the basement and the first 3 floors. The 4th floor is completed up to the walls and the insulation. The 5th floor is completed up to the structural frame and the insulation. We select the first phase, which is the structural frame with its insulation. We can inspect the basement and the foundation. The second phase is the grout concrete. The next phase is the walls with the embedded thermal insulation. The fourth phase is the implementation of frames. The fifth phase is the plasters. We can move around and inspect the 3D building by using only the mouse. Using the virtual reality tool, we can hide the various layers of a specific area. We can view and inspect the building in floor plan view. We can also select to display the created sections and front views. We can even view and inspect the 3D section of the structure. Based upon the BIM process, HoloBIM produces detailed and precise data for the position and properties of every reinforcement bar. We can use the 3D virtual environment for the visual verification of the reinforcement list accuracy. We will now produce the quantity takeoffs lists for all materials and labor. All the required data is available for the automatic calculation of the materials quantities and the cost for the construction of the building. It only takes a few seconds to produce the complete quantity takeoffs. This is the concrete and formwork list. This is the reinforcement bars list. For every floor and every structural element. The total reinforcements for all longitudinal bars and stirrups. Thermal insulation list per floor and in total. The cost estimation for the construction of the structural frame. The detailed geometry and quantities list for every wall. Total cost estimation for the construction of the walls. The quantities list for all doors and windows. The cost estimation for all openings. The quantities survey for plasters. This is probably one of the most difficult and time-consuming lists to produce in buildings. Cost estimation for plasters per square meter. The materials quantities for floorings. And finally, the cost estimation for the construction of the building, up to the plaster phase. With HoloBIM we can inspect our building and make the required modifications easily, safely, and almost instantly. For example, we want to increase the floor's height to 5 meters. A few seconds are enough for the update of all construction drawings and quantity takeoffs. The 3D model is instantly redrawn. The geometry, the dimensions, the drawings, and all quantities lists are updated automatically after any modification. The sections have already been updated to reflect the changes we made. The elevations and dimensions have been adjusted automatically, and the wall we deleted is not displayed anymore. We can also inspect the changes in the 3D model of the section. With these simple actions and tools, we can monitor and adjust the design process and the possible modifications, and finally deliver the detailed project documentation for the building. In our channel in YouTube, you can also watch the video for the structural design module of HoloBIM, which uses the same input demonstrated already in this video. Thank you for watching our video presentation.